Good morning. This lesson is for my integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of are 3 goals for the day. Our first goal is going to be to define relation and function notation. Our second goal is going to see multiple representations of relations. And our third goal is going to be to define domain and range. So let's just go ahead and jump right into our first goal. A relation is a rule that maps an input to an output. It's super vague, but you guys, you'll see how actually simple this is. So here's going to be an example of a relation. I'm going to plug x equals 4 into the equation y equals 3x plus 2. All right, y equals 3x plus 2, this is a rule. Okay. So let's go ahead and work this out. So I'm plugging in x equals 4, that is my input, and when I plug it in, that will be mapping to the output. So we're going to get y equals 3. I'm going to replace my x with a 4. I'm going to add 2 to that. 3 4s is a 12. 12 and 2 is going to get me to 14. So y is equal to 14. So my input was 4, my output was 14. Input is 4. The rule was y equals 3x plus 2, and that gave me the output of 14. Okay, so that's an example of a relation. You plug in something, you get something back. A vending machine is a physical example. You put in money, press a button, you get back the right product. All right, so that's what a relation is. And we'll get a little bit more into it, but I think that's good enough for what we need. The next thing we're going to talk about is function notation. And I'm going to tell you that f of x is equal to y, and this is how it translates. F of x equals y, and this means that f of x is interchangeable with y. Sorry about that. It's interchangeable with y. I like to, in class, I like to ask students if they understand what this word means. Really? Yes. Remember, it's interchangeable with y, so hopefully that helps you to remember what it represents. Now, what is the advantage of f of x versus y? Well, I'm going to have the same rule written in 2 ways, one with a y and one with the f of x. Okay? And I'm plugging x equals 2 into both of them, and I'm going to work them out through the rule. So I'm going to plug in x equals 2 for this one, so y equals 5 times 2 plus 6. 5 2's gets me to a 10. 10 and 6 gets me to a 16. So here I get y equals 16. That's my output. I'm going to compare it to this, the function notation. Everywhere I have an x, it's going to turn into a 2. So now I'm going to have f of 2 equals 5 times 2 plus a 6. 5 2's is a 10. 10 and 6 is going to get me to 16. And now I can say that f of 2 equals to 16. Now, here's the advantage. Why is this better? Because if I have just this, I know that my input is 2, my output is 16, where over here, I don't know what the input is. But I know what the output is. The output is 16. So the advantage of function notation is it tells you what the input is. All right, I'm going to go ahead and check off the first goal. I'm going to come back with the second goal and talk about multiple representations of relations. And I think I can fit define domain and range into the same edit here. So let me clean all this up and I'll be back. I'm back. So let's go ahead and continue with this lesson, and we're starting off with the second goal here, which is multiple representations of relations. So we saw in the first goal that x is the input and y, or f of x, is the output. We're going to see multiple ways to represent x and y. And again, we want to see how to represent relations, and relations are input, which are x values, output, which are y values. And so here I have all of the ways that we can represent relations. Now I said the rule A maps to B. So my input A gets me output B. C maps to D. Input C gets me to output D. I have 5 ways that I can represent an X and a Y value, or an input and an output. So the first way I can represent them is ordered pairs. A comma B represents this. C comma D represents this. I plug in A, I get B. I plug in C, I get D. That's what that means, ordered pairs. And they're called ordered pairs XY because they're in the order of the alphabet. Graphically, now I don't know if A has a larger value than C, or C has a larger value. I just put them in alphabetical order. Same with my Y values. So the ordered pair has a horizontal value of A and a vertical value of B, so that would be a graphical representation of an input A, output B. This would be a graphical representation of a input C with an output of D. All right, that's what it's going to look like graphically. As a table, I have my X and Y column, which could also be my X and my F of X column, because remember F of X and Y are interchangeable. But my input A makes output B. Input C makes output B. Again, I could have Y or F of X, but input A, output B. Input C, output D. So that's the third way that I can represent a relation. The fourth way is what's called a mapping diagram. Basically, you draw a bubble, put all your inputs in one bubble, draw another bubble, put all your outputs in that bubble, and draw arrows from which input it gets to that output. So A maps to B, C maps to D. And finally, function notation, which we just saw in the previous section. Again, if I plug in A, I get B for my Y value. If I plug in C, I get D for my Y value, or my F of C. All right. So that is multiple representations of relations. Oh, one more thing. What does 3, -4 imply? It implies we plug in 3 and got back 4, right? Input 3, output. Now, do I know how I got to that? No. But I know that if I plug in 3, I get -4. All that I know. All right, so now let me check off that second goal. All right, and I'd like to lastly talk about defining domain and the range. The third goal, domain is a set of all inputs. Using this example over here, I could say that my set of all inputs would be A and C. Those are the values that we plugged in. So the domain is going to be A and C. All right. The range is a set of all outputs, the values that we got back. Now, I know it's a little goofy using letters, but it's the same idea. Hopefully this idea is translated. All right, the range is going to be my values that I get back, and that's B, comma, D. All right, so those are all my outputs. So if you weren't here today, this was what you missed. We didn't do any homework. We just learned about what relation is, what function notation is, the ways to represent relations, which are X and Y values or inputs and outputs, and what domain and range is. So I'm going to go ahead and check this last goal off. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.